So, with having said all that, we are excited to announce our first keynote of the day. So, this is a talk on scaling the stage. So, managing 200 plus plugins and thousands of engineers. So, with that, I am going to add Vincenzo to our stage. He comes from us from Spotify. Welcome, Vincenzo.
Hi, guys. Thank you for having me.
Awesome. So, with that, we will remove ourselves and let you take it from here.
And don't forget to give yourself a proper intro. We didn't really do that one justice.
Amazing. Sounds good.
Okay,
Sounds
Vincenzo,
good.
thank you.
Thank you so much. Hi, everyone. So this talk is going to be all about scaling out Backstage with a focus on the backend. So this talk is for those of you who have deployed Backstage at scale and are struggling with scaling out, or for those of you who have learned who want to learn more about how some internals of Backstage work. Before we start, let me introduce myself. Hi, my name is Vincenzo, Vinscam on internet. I'm a senior engineer working at Spotify. I live in Sweden, where I moved 9 years ago, and I'm part of the core team of Backstage, working with the core framework. And this is our agenda for today. So first, we will start by having a look at the Backstage monorepo, just to understand more what you get out of the box when you boost up a new Backstage app. Then we will learn more about how plugins communicate between each other. Then we will dive into the core section of this talk, where we will describe different methods for scaling out Backstage, and where we will going to talk also about things you need to configure in order to distributively deploy Backstage. We will have a look at the Spotify internal developer instance deployment, and we will conclude with some final recommendations. Cool. So I would like to start this talk from the basic, just describing how you create a Backstage app from scratch. So you usually do that by running this script, backstage/create-app. And if you run this module, this is going to create a new repository on your machine containing a JavaScript project with a Yarn monorepo. Then if you look at the structure of your project, you will notice that there will be a plugins directory in your repository, which is the place where you can start building your own custom plugins in order to start building your developer portal on top of Backstage. And with your custom plugins, you can also install open source plugins directly in the repository. And once you run this command, yarn start-backend, the magic will start. The command will basically discover all the plugins that are installed in your repository, bundle that together, and run Backstage in a single app. This is really straightforward. And one interesting thing about Backstage is that plugins aren't just isolated modules, but they can share data between each other. And the way the data is shared is very particular. It might be very confusing. At least it was for me when I started working on Backstage. I remember 3 years ago, I was working on one of our commercial plugins that we built at Spotify. And at a certain point, I had to retrieve some data from another plugin. And for simplicity, let's imagine that I was working on just building a to-do plugin, building the classical to-do app. And that at a certain point, I want to extend the functionality of the to-do app by visualizing some information about the author of each to-do, assuming that those authors were ingested into catalog as user entities. So basically, I had to retrieve some data from the catalog plugin. So I didn't know how to do it, so I just tried to see if there was any other plugin that was doing the same in my code base. And I found out that there was a handy catalog client class which contained a bunch of methods and the method I was looking for, getEntityByRef. So I just copy paste some code, and yeah, it worked. I basically retrieved the data I wanted. I implement the feature at the first shot. It was really simple, and it was so simple that I was curious to know more about how Catalog Client worked. So I just dug into the source code of Catalog Client, and I found something interesting. Let me show the source code. So this is the method, the source code of the method I was using for retrieving my data from catalog. So I've simplified a bit, but this is essentially what it's doing. So if you're familiar with some web development, this is a typical REST request. So this means that my plugin was attempting to communicate with catalog plugin by REST request in order to retrieve the data wanted. And honestly, I thought this was a bug because I knew that both plugins basically were living in the same app. So why should my plugin instantiate communicate via REST request to catalog plugin instead of just grabbing the data somehow internally? So I thought it was time to ask for an advice from some colleagues. And I actually thought that this was a bug. I was like reach out to the team claiming that this was a bug. And then some of my colleagues make me notice that this wasn't a bug, but actually this was done on purpose, because the fact that both plugins live in the same process is not always guaranteed. And I was still confused because like I knew that both plugins were running in the same process on my machine. So why was this needed? And this was because it was needed because they were running on my machine on the same process on my machine because I was using the default deployment option. But additionally, there is a possibility to deploy the plugins separately. And this was magic because I didn't know this was possible. So basically, you can deploy plugins into different places, and Backstage know how to reach out to each plugin. And the magic behind how Backstage can resolve the address of a plugin is inside an internal service called Discovery Service. So if you remember the snippet of code of catalog client I showed you before, Discovery Service was there. You just pass the name of a plugin to Discovery Service, and Discovery Service give you back the address of that plugin. So this is where the dark secret of Backstage was. So now I was curious to know how this worked. So I dug into the source code of Discovery Service, and I found something even more interesting. Here it is. So yes, Discovery Service can resolve the address of any of the plugins, but unfortunately, batteries are not included. So just to better explain what the default implementation of Discovery Service is doing, the default implementation assumes that all plugins live in the same Backstage app. So if your goal is to distributively deploy the plugins, you need to provide your own implementation of Discovery Service. You can do that by providing your own class for Discovery Service, implementing this get base URL method. But actually, there is an easier way. This is something we have released less than a year ago. And you can, in case the address of your plugin don't change, is static, you can configure your Discovery Service using appconfig by defining different targets directly in appconfig. So in this example, I've defined a target for the catalog plugin and another target for auth and permission plugins. And in case multiple plugins use the same pattern, you also have this possibility to reuse a target, a kind of pattern as shown in the second target. So remember to provide your own Discovery Service implementation if you want to distributively deploy Backstage. But what if you don't? Well, in some cases, you can skip customizing it, but this depends on the approach that you use for scaling out Backstage. Let's explore a few of them. So let's go with the first approach. So this is my representation of a Backstage app. So you have some core services at the bottom, such as logging, appconfig, CLI, and so on. And then I have some plugins attached to that instance. In this example, I have 6 of them. So the approach for scaling out Backstage would be to just replicate the instance as it is, putting a load balancer on top of the instances just for routing the requests. So this approach is valid. Pros and cons of this approach. This is very easy to achieve. You just replicate the instance as they are, and that's it. You don't have to change any code or toggle any internal configuration. It just works. But the downside is that if you have a plugin that consumes more resources than others, for example, receive more requests or consume more memory or even steal the JavaScript event loop, that plugin can cause other plugins to starve to the point that they couldn't serve any request. And the other issue is that plugins can only communicate with other plugins within the same instance. Remember, we haven't customized Discovery Service so far. So for example, if the Kubernetes plugin wants to retrieve some data from the catalog, it can only reach out to the catalog client that is present in the same Backstage instance. So this approach has some drawbacks. There is another interesting approach. This is useful in case you have a specific plugin that consumes more resources, a plugin that deserves a very special treatment. So in that case, you can move that plugin out from the main instance. So in this case, I have a the catalog plugin, which have been moved out from the main instance, and catalog now won't affect the other plugins. And you can scale the catalog plugin in a different way. You can give more memory or scale it differently. So this is another approach that you can use. How you can achieve this? So you can do this by conditionally enabling plugins. So in this case, I have enabled 3 plugins in the main instance, Scaffold, Search, and Kubernetes. And I've also enabled Catalog on a secondary instance. And it's up to you how you want to implement the flag for detecting whether you are on the main or secondary instance. You can use a config, environment variable. This is up to you. It's just JavaScript. So pros and cons of this approach. Now you have more control in case you have a greedy plugin. This is very straightforward to achieve because code changes are the needed code changes are minimal, but still plugins can only communicate with other plugins within the same instance. But now the problem is actually bigger. If we go back to the previous example where the Kubernetes plugin wants to retrieve some data from the catalog plugin is not even present in the main instance anymore. So you will have a communication problem unless you configure Discovery Service properly. So a proper configuration of the Discovery Service is vital in this approach. And before we continue with the third approach, which is actually the one we use at Spotify, I want to pause for a moment to reflect that we have simplified things a bit until now, because things get a bit more complicated when we bring service to service auth to the table. Service to service auth allows plugins to accept requests coming from legitimate Backstage plugins by requiring a special token signed with a special secrets. And since the plugins are now distributively deployed, you need to make sure that plugins can understand each other. So you can do this by sharing the same secret to the various instances. So remember to provide the same secret in app config of each plugin. Or in case you have hardened requirement, there is also a possibility to provide a more granular access control by specifying multiple secrets. So if you do that, the first key is going to be used for signing the request, while the other keys will be used for validating the request. So this means that you can set up a kind of asymmetric configuration where some plugins don't have access to other plugins. By the way, there is development ongoing in this area. We are improving this process, and in the near future, you won't need to provide any secrets because plugin will kind of configure service to service auth automatically, and there will be a mechanism for plugins for authenticating the requests between each other. So stay tuned. Cool. So now that we have briefly covered service to service auth, let's dive into the third approach for scaling out Backstage, which consists of deploying each plugin independently from the others. How you can do this? So you can achieve this by creating multiple small Backstage instances, typically living in different repositories, each one of them containing just the core Backstage features and the code of a specific plugin. By using this approach will give you the benefit of scaling each plugin independently, and plugins won't affect each other. But I think there are stronger benefits than scaling, because as each plugin will live in its own repository, this approach will set a clear ownership of who owns a specific plugin. So each plugin can be owned by a different team, and they can own that plugin end to end, from maintaining the code or making sure that everything works as expected. On the other hand, the drawback of this approach is that maintaining the infrastructure around all this plugin is going to be hard. Imagine just upgrading Backstage. Now you don't have just a single Backstage instance that you need to upgrade, but you have a lot of small Backstage instances that you need up to date. And of course, discovery service need to be proper implemented as well. Cool. Now that we have covered all three approaches, let's dive into a real-world example by diving into Spotify's internal developer portal deployment. And this is going to be tricky because the internal Spotify developer portal is more complicated than a normal developer portal built on top of Backstage for historical reasons. So if you look at the history, Backstage was created in 2016 there, and it was initially called System Z. But the open source version that we all use today, it was released in 2020. And the open source version is actually a different product than the original, let's call it legacy Backstage that we created at Spotify. The technology is different. The backend of the internal Backstage was written in Java, while the open source Backstage is written in Node. And the APIs are different because we improved the API, because we learned from our mistakes. So in 2020, we ended up in a situation where Spotify need to migrate to the open source Backstage as soon as possible, because the speed of the open source Backstage was insanely faster compared to our internal Backstage. And that's probably the reason why Backstage is hard to compete with a product like Backstage. So we decided to move to Backstage open source and kind of move away from the internal old Backstage. But the concept around our internal Backstage weren't all bad, because there were a few things that we wanted to keep when migrating to Backstage open source. Specifically, we had more than 100 plugins that we have developed during the years at Spotify internally, divided by front and backend plugins. And of course, we want to keep those plugins up and running. And those plugins weren't basically built by a single team, but instead they were built distributively inside Spotify. So you have like each one of them was built and maintained by a different team, and they were basically living in different repositories. And this approach, this is something worked really well for us, and this is something we want to keep when migrating to Backstage open source. And this is the reason why we chose the third approach, to deploy each backend plugin separately from the other. So at the top, you can see our own old Backstage backend. It was a Java app with a bunch of GraphQL resolvers fetching data from the underlying services. And at the bottom, you can see all the new plugins built on Backstage open source, and all the open source plugins as well, deployed separately. So each one of them live in its own repository, and it's deployed separated from each other. And this is something that really worked well for us, because then you can also step by step migrating the plugin, because both the legacy Backstage and the new Backstage can live together at the same time. And now, I hope it's clear the reason behind the approach that we use for deploying Backstage. But This doesn't mean, I want to be specific, this doesn't mean that deploying the plugin separately is the recommended approach, because actually it isn't. All the approaches that we have described today, they are valid. Each one of them has strengths and weaknesses. But of course, if you choose the third approach to deploy the plugins separately, then of course you will have absolutely freedom about how you want to scale each plugin. But the drawback is that maintaining Backstage is going to be more complex for you. And if you don't have the right tools, for example, such as Fleet Shift, a tool that we have developed internally, which allow us to make changes to multiple repositories in one shot, this is going to be more complicated for you. So please choose wisely. Remember to configure your discovery service in case you want to distributively deploy Backstage, and choose a good service-to-service auth strategy that fits your organization requirements. Before we end, I would like to invite you to the Spotify for Backstage webinar next week, where we will present Spotify portal for Backstage, a fully featured internal developer portal built by us at Spotify. We will also share updates on our bundle of productivity boosting plugins, and you will learn more about how you can tap directly into Spotify's expertise through our enterprise support offering. So join us. I leave a QR code there, and thank you so much.
Awesome. Thank you, Vincenzo. I'm just going to leave your slide up for a minute or so while we wrap up so that if anybody wants to scan that, they can. I loved what you said around the third approach and the freedom to scale. And I think that's so important for anybody who is working in this space and, the decisions they're making to make sure that they are completely scalable. I just wanted to cover, there was one question. And if you do have any questions for Vincenzo, please put them in the chat now. We can read them out. We did have one question, and you kind of talked about it or alluded to it, but I want to make sure we definitely answer Nicholas's question, which is, can't we maintain just one repository and just start it with different flag in order to run specific plugins in each instance?
Yeah, great question. Yeah, this is another approach. I mean, the approach we have described today, they're not the only approaches. They are definitely more out there. This is something you can do it. The drawback of this approach is going to be that we could have gone in that direction, but we didn't, because we prefer to have different repositories. Because if you keep everything in one repository, the problem is that repository is going to be shared by a lot of teams. So that means that you can't set a clear ownership of who owns that repository. And yeah, this is the drawback of that approach. But that's another way. This is absolutely valid. So if you don't care so much about ownership, this is a valid approach, definitely.
Awesome. Well, for anybody who's still who's here, again, Vincenzo, I think you'll probably hang around in the comments for a few minutes.
Definitely.
Ask questions there. Thank you so much for kicking off KubeCrash and our keynote today. And with that, I'm going to remove you from the stage. Thank you.
Thank you. Thank you so much.